Okay, so today we're going to do the 8.2 notes, and we're going to graph some rational functions. So a rational function has the form where you have one polynomial, p of x, divided by another polynomial, q of x. So polynomials, if you want to think back, that's what we were doing not too long ago, but you have to have all of the exponents have to be integers. Okay, so the inverse variation function is going to be a divided by x. And that's what we were doing in that last section. So the parent function for 1 over x, where a is just 1, is going to look something like this. You have your vertical asymptote going through x equals 0. Remember, vertical lines are x equals. And you can see that that is correct because in the denominator, x cannot equal 0. Then you can plug in some points to get the rest of the values. So at 0, I know I can't do, that's going to be undefined. Let's see what happens at 1. Well, 1 divided by 1 is 1. So at 1, I'm at 1. What about at 2? I would be at a half. Well, what about if I go backwards at a half? 1 divided by a half is the same as 1 times 2, which would give me 2. And you could do that also with the negatives to see what your graph is going to look like. So let's graph 6 divided by x and then compare with the graph of 1 divided by x. So I'm going to go ahead and get a table for this. And let's see, I know that I cannot have 0. That's going to be my vertical asymptote. So let's get some values before and after 0. Well, let's see, let's plug in 1, that will work. So when I plug in 1, 6 divided by 1 is 6. Two would give me 3. 6 divided by 2 is 3. I'm going to skip, oh no, I can do 3. 6 divided by 3 is 2. And let's go ahead and jump out to 6 so I can get a nice integer. That would give me 1. So there's this part. And let's graph the other part over on the negative side. So let's maybe do -1. It's going to give me -6. -2, -3. -3, -2. -6, -1. So what else do you notice about this graph? Besides it having a vertical asymptote, do you see any more asymptotes? I also see a horizontal asymptote at y equals 0. And we'll get into that a little bit more as we continue. So how does it compare with the graph of 1 over x? Well, basically, when we had the 1 over x, all we did was take all of those values and multiply them by 6. So you have your vertical stretch of 6. What's our domain going on? So the domain looks like everything except x cannot be 0. What about the range? Good. Y cannot be 0. And then we already labeled our asymptotes. So now we're going to graph translations of a simple rational function in this form. This is going to have an asymptote, a vertical asymptote, where the denominator is 0. And then this guy over here is going to be my horizontal asymptote. So this would be a vertical asymptote, this would be a horizontal asymptote. Then we can plot some points just like we made a table and sketch the graph. So let's look at this one. First thing I'm going to do is identify my vertical and horizontal asymptote. So I have a vertical asymptote at x equals -2. Then I have a horizontal asymptote at y equals -1. And so now I can get some points around that -2, around x equals -2, and plot those. So let's see, at -1, if I plug that in, -1 plus 2 is there is 1, -4 divided by 1 is -4, minus 1 would give me -5. Go ahead and get some more of those. Fill in your chart and see if you get the same as me. So as I draw them, I'm going to make them approach the asymptotes. All right, you try those next 3 on your paper and see how you do. And when you come into class tomorrow, let's check with your group. So pause me, and then you can continue. Okay, so another form of a rational function could look like this. So if you have 2 equations that have those same degrees going on, now you still have a vertical asymptote where the denominator equals 0. So you could solve for x. So that's your vertical asymptote. But now your horizontal asymptote, when you have the same degree on the numerator and denominator, is going to be the leading coefficients divided by each other. And you need to write that as an equation again. Asymptotes are lines, so you have to put y equals a divided by c. Let's try this one. So these guys have the same degree. They're both a degree of 1. So let's find our vertical asymptote first. I got x equals 3. And now since they're the same degree, I can take the leading coefficients and I get y equals 2 over 1, which is 2. So your horizontal asymptote is y equals 2. try some different ones. Feel free to put it in your graphing calculator. I rounded there a little bit. So I was just picking some to help me get the sketch going. I'd get at least 3 on each side. So look something like that. Okay, you guys try these next 3 on your own, and again, we're going to check these when we get into class tomorrow, and we'll see how you did. And hopefully you're pretty good at doing these graphs, and I'll see you tomorrow.